Hi friends, this is Swami. I should deal chemistry, NEET and JE point of view. So today we are going to discussing topic is a states of matter. Today we have to discuss only introduction point of view only we have to discuss now. So introduction means so what we have to discussing in that introduction means right. So first states of matter, that matter can be classified into three ways. So matter can be classified into three ways. So one is a solid and another one is a liquid and another one is a gas. So how the compound can exist in solid, liquid or gases? So how we should say whether that compound is existing in that solid, liquid or gas here. So which can be depends on two factors which can depends here. So one is a intermolecular forces. Then another thing is a thermal energy. One is a intermolecular forces, then thermal energy here. So in case of solid substance, how can it existing in that solid substance means intermolecular forces having more, then thermal energy will be less. So that can existing in that solid, right? So this intermolecular forces will decreases when compared to this one. So that can existing in that liquid. So then very less intermolecular forces are present in gaseous molecule, but high thermal energy. So that can existing in that gaseous molecule. Yeah. So generally this gaseous molecule only means gaseous state only we have to discussing in that states of matter. This states of matter we have to say as a gaseous state also. Gaseous state also we can call. Right. So in that gaseous state too, so what we have to discuss in that introduction point of view in gaseous state means so first in gaseous molecules, so from one molecule to another molecule, so what type of interactions are present here? That interactions we have to discuss in this introduction point of view. Yeah. So in that introduction point of view, so what are the interactions are present here means generally these are having that vander Waal interactions. So what are these van der Waal interactions here? Van der Waal is a scientist name. His name is a van der Waal is a scientist name. So in this van der Waal can explain some interactions in a molecule. That interactions we have to discussing in that introduction point of view. Yeah. So what are these interactions are present in this van der Waal here means right? And generally before going to this van der Waal interactions, so first we know what is the difference between the two polar and non-polar molecule, right? So in that polar and non-polar molecule, so whether the molecule is a polar and non-polar molecule, how we should say then whether the molecule is a polar or non-polar molecule means, so one thing we have to calculate this whether the molecule is a polar and a non-polar molecule by using that dipole moment. By using a dipole moment, we can calculate whether the molecule is a polar molecule or a non-polar molecule. Yeah. So one more thing, how we should differentiate this polar and non-polar molecule means, if we are taking example means that we can define here. Right. So let us say for example, we have a HCl molecule we have. In this HCl molecule, when compared to hydrogen and chlorine, so chlorine is the most electronegative element. So the electrons are attracting towards chlorine and it will get a partial negative charge and hydrogen will get a partial positive charge. In this HCl having a polarity means having positive and partial negative and partial positive charges. This we have to say as a polarity. Means so this molecule we have to say as a polar molecule. Right? So non-polar molecule means what here means. So let us say for example H2 and I2 molecule we can take as example. So H2 molecule we have. H2 molecule. This is an H2 molecule. Right? So then let us say for example I2 molecule we can take here and it is an I2 molecule here. Right? In generally H2 molecule then I2 molecule, in between this H2 molecule and I2 molecule here here there is no polarity here. There is no polarity here. But these molecules will get polarity. So when it will get polarity here means when these two molecules are interact with other molecule, so on that time it will get a polarity. So then this is a non-polar molecules. We can take as an example for these two cases here. Right? So in generally van der Waal interactions we have a different type of van der Waal interactions we have. That what are these different type of van der Waal interactions? So that we can discuss now. Now, so what are the van der Waal interactions are present here means we have a different type of van der Waal interactions. So now we discussed in that polar and non-polar. So generally in between two polar molecules, in between two non-polar molecules, one is polar, another one is non-polar. So in between these molecules only having a interactions, right? So that interactions we can see now. So first interaction is a ion and dipole, ion and dipole. Then second interaction is a dipole and dipole. Then third interaction is a ion induced dipole. Then fourth interaction is a dipole and induced dipole. Then fifth interaction is a induced dipole and induced dipole interactions. So these are the 5 interactions. So in generally we are discussing in that van der Waal interactions. So in these 5 interactions, so first ion dipole interaction means what? Dipole interaction means what? Ion induced dipole means what? So dipole induced dipole means what? And induced dipole means what we can discuss now, right? So in this interaction between ion and dipole here. So ion means we can take any positive or negative charge ion. So let us say for example if I take here negative charge ion means, right? So here dipole means we know na polar molecule we can take here HCl. So we know in that HCl is having that partial negative charge and partial positive charge. And Cl minus ion, it is having that negative charge. In between these molecule having a interaction, so these interactions we are calling as a ion dipole interactions. So ion dipole interaction can be formed between a ion and a polar molecule, right? So this is a strong interactions. So when compared to these remaining, so these are the strong interactions are present in this. Right? So next another one is a dipole interactions. So what are these dipole interactions means? So the interaction between a two polar molecules here. So polar molecules 2 means so HCl, then HCl we can take example now. So this is an one polar molecule, it is an another polar molecule. It is having partial negative, partial positive charge, partial negative and partial positive charge. Interaction between these two molecules, so we can say as a dipole interactions we can call. So this dipole interaction can be formed between a two polar molecules. So this is a weak interaction than this one. When compared to this interaction, it is a weak interaction only. Then ion induced dipole. What about this ion induced dipole here? So which means so in generally ion means we can take here positively charged or negatively charged ion. Whatever we can take this ion here. Then induced dipole means so it is a non-polar molecule we can take. Non-polar molecule means H2 molecule we can take as example. H2 molecule is taken example. In generally H2 molecule, in this H2 molecule here there is no polarity here. But when this H2 molecule is interact with ion, which can create itself a dipole. So which means so hydrogen will get a partial negative charge and partial positive charge. When it is happened in that, when it is interact with other molecule or other ion, so on that time which can create itself dipole. Clear? So that's why we have to call as a induced dipole. induced dipole. So induced dipole meaning is what here means. So then there is no dipole. In generally here there is no dipole, but which can create itself in dipole. So that is nothing but a induced dipole we can call here, right? So interaction between ion and ion in the so then non-polar molecule, right? So this interaction we are saying as a ion induced dipole interactions, right? So these are weak interaction when compared to these two. When compared to these two, these are the weak interaction here, right? So next dipole and induced dipole, right? So dipole induced dipole means we know dipole means which molecule we can take, polar molecule we can take as example. So polar molecule means HCl we can take as an example now. So it is having that polar charge, partial negative and partial positive charge. Then induced dipole means so this only H2 molecule only we can take as an example. Here in between in this H2 molecule there is no polarity here, but which can create itself polarity. So that we are saying as a induced dipole. So interaction between polar and non-polar molecule. Interaction between polar and non-polar molecule. This interaction we are saying as a dipole, induced dipole interactions we can call. Right? So these interactions are weak interactions than above 3. When compared to these 3, it is a weak interaction here. Right? So last one is a induced dipole. So then interaction between a two non-polar molecule we can take as an example here. So non-polar molecule means so then H2 molecule or I2 molecule, whatever we can take here. So here H2 molecule and H2 molecule. H2 and H2 molecule. Here there is no there is no polarity here, but which can create itself in a polarity. That we are saying as a induced dipole. So which can create itself in a partial negative and a partial positive charge, partial negative and a partial positive charge. Right? So interaction between two non-polar molecules, that interaction we are saying as a induced dipole interactions. So in these interactions in generally we are saying as a London forces also. Right? So London is a scientist name. So he had explained these interactions. So that's why we have to call it as this London forces also we can call this one. So these are very weak. Interactions than above, right? When compared to this one. So these are the very weak interactions here, right? So these are the 5 types of interactions. So in generally we have to discuss in the interactions. So based on this, they have to ask questions also. How they are asking that questions? So any 1 or 2 questions we can discuss now. See here. So then based on this, we have to solve some questions. How they are asking that examination point of view. So in generally we know that what is the correct strength of these interactions here. So first ion dipole is greater than of dipole, then greater than of ion induced dipole. So dipole induced dipole. So induced dipole are London forces. Clear? So this is the correct order for that interactions of that different type of interactions here. Then first question number 1 we can see here. Write the correct order for the following here. So what is the correct order for this following here? How can we compare this one? So that we can see here. So in between ion and dipole. So that interaction we are saying as a ion dipole interaction. So H2 molecule. In between that H2 molecule, what type of interactions are there? So let us say for example this is 1, this is 2, and this is 3, and this is 4, and this is 5th one. Right? So in generally this is ion and HBr. What type of interactions are there? Ion dipole, that is first interaction. Then in between H2 molecule here, so 2 H2 molecule, induced dipole, that is a London forces are there here. This is 5th one. Then, so in between that 2 HCl molecule, what type of interactions are there? Dipole interactions are, that is 2. Then in between that ion and induced dipole. So this ion and induced dipole interactions will be there. So this is ion Cl minus H2 molecule is a induced type. So ion induced dipole interactions are there, and this is a 3. So what is the correct order for this following here? Which means So in that first one is there, na? This is first one is greater than of, next which one is third one is greater than of next. So 3 means fourth one, next second one. So this is the correct order for the following interactions. Yeah. So like this they have to ask a question. Then so then we can see this question here. So F2 Cl2 then Br2 I2 molecule. So in between F2 molecules, what type of interactions are present here? Induced dipole and the induced dipole interactions are present here. So in between F2 molecule here, induced dipole and induced dipole interactions only present. In between Cl2 molecule, same London forces only. In between Br2 molecule, same London forces only happen. In between I2 molecule, same London forces only present here. If same forces are arises between these molecules, so how can we compare this question? Which one is having that more interaction, then which one is having that very less interactions? So how can we compare this one? Means so in this case, that strength will be then the strength or interaction which is directly proportional to molecular weight. Molecular weight. We know that fluorine atomic weight is 19, fluorine is 35.5, and bromine is 80, and this is 127. So which one is having that higher weight? So that is having that more interactions here. So that's why what is the correct order we have to write here? And that fourth one is greater than of third one, is greater than of second one, is greater than of first one. So like this we can compare. If same type of interactions, all are having a same type of interaction, so how we should compare in this one? So depending upon the molecular weight. So which one is having that high molecular weight? So that we can say as a more strength here. Then one more thing. So then HF molecule, then HCl molecule, HBr molecule, then HI molecule here. So how can we compare this? Right? So all are having, in generally what we have to think here. So HCl, HBr, then HI molecule, HF molecule. What type of interactions are present here? In generally what type of interactions are? So dipole interactions are present here. In between HCl molecule already we discussed HCl, then HCl. So what type of interactions are present here? It is having that partial negative, partial positive, partial negative and partial positive charge. In between these having a dipole interactions are present here. Right? So all are having that dipole interaction means so what is the correct order we have to write here means so in generally what is the correct order we have to write here means so generally what is the correct order for this one means so then HI molecule means fourth one. So fourth one is less than of HBr and less than of HCl than of HF molecule. If we are writing this order means so it is completely wrong only. It is completely wrong only. Why? What is the reason for this case? So generally same type of interactions are present means so what we said here, that strength which is directly proportional to molecular weight we said na. So all are having the same type of interactions only. So why can't it is wrong here? Because in generally we have to discuss here some type of interactions here, right? So in generally, so we have a different type of interactions. So first one is a ionic. First one is a ionic interactions. Then covalent, then hydrogen bonded, then van der Waal interactions. Right? So this ionic and covalent, these are very strong interactions are present here. If strong interactions are present here means so generally what about its bond energy means so its bond energy nearly then greater than of 200 kilojoule per mole. This much of bond energy is presenting in ionic and covalent bonds here. Then hydrogen bond means so hydrogen bond also it is very strong bond only. In this case from 8 to 42 kilojoule per mole. So this much of bond energy is present in that hydrogen bond. Van der Waal interactions are very weak interactions. So in this case which is having a so less than 8 kilojoule per mole. Less than 8 kilojoule per mole. This much of bond energy is presenting in the van der Waal interactions here. So hydrogen bond means what here? So hydrogen bond can be formed in between hydrogen and most electronegative elements like fluorine, oxygen, then nitrogen here. In between these, so in between these can form a, in between these two molecules can form a hydrogen bond here, right? So here the HF molecule is there now. HF is a HF, in between that HF molecule so can form a hydrogen bond here. So that's why hydrogen fluoride, that is HF molecule, in between that HF molecule so having a hydrogen bond. It is not a van der Waal interaction. So that's why what is the correct order we have to write regarding this one is so here the HF molecule. I'll write here. So HF molecule is greater than of HF molecule is greater than of HI molecule, then HBr, then HI molecule. Sorry, HCl molecule. Right? So this is the correct order for the following given. Clear? So these are these type of questions they have to ask in a examination point of view. Clear? Thank you. So if you are liked my video, please do subscribe. Thank you.